Hello all. In this lecture we discuss the quadratic residue system and how we can calculate the quadratic residue for a modulo prime number and a quadratic non-residue for a modulo prime p, and what are the quantity, how many numbers are there for a quadratic residue modulo p. So see the statement of that theorem. That theorem says that if p is an odd prime, then there are exactly p minus 1 upon 2 incongruent modulo p quadratic residue, and also exactly p minus 1 upon 2 incongruent modulo 2 quadratic non-residue mod p. And what are that residue? That residue classes containing the numbers, if p is an prime, then the residue classes containing number 1 square, 2 square, 3 square up to p minus 1 upon 2 bracket square. Okay, so this is a formula for finding out a quadratic residue mod p. So see the example. If we have to ask, if the question is that find the quadratic residue mod 13 is a prime. So by using that theorem, we have the quadratic residue. Exactly what are the numbers of quadratic residue? 13 minus 1 upon 2, that is 12 upon 2, 6. So there it has that modulo 13 has exactly 6 quadratic residue, and which number are 1 square, 2 square, 3 square, 4 square, 5 square up to 6 square. So this is a quadratic residue modulo 13. 1 square 1, 2 square 4, 9, 3, 12 and 10. This is a system of quadratic residue modulo 13. Same way we can calculate a quadratic residue for 17. Again 17, it is a prime number. Then 17 minus 1 upon 2, that is 16 upon 2, answer is 8. So it has 8 quadratic residues and 8 quadratic non-residue. Then how we can calculate the quadratic residues? So up to 8 square, that is 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, 7 square and 8 square. So up to 8 square, this is a quadratic residue mod 17. So by using that direct formula, we have to easily calculate a quadratic residue for a modulo prime number p only. Okay, so using the previous previous recording lecture theorem, or at the time of starting theorem, we say that, or we prove that there are exactly p minus 1 upon 2 quadratic residue or as well as quadratic non-residue modulo prime number p. Now we are going towards the next important part, that is the legendary symbol. How we can calculate the legendary symbol? First upon see the notation of legendary symbol. This a upon p, it is not actually a upon p, or it can be denoted as a by p. So this is notation for either this one or this one. This is notation for legendary symbol, and it has a definition like that. The legendary symbol of a upon p, actually if we can write down a upon p or a by p, it has a meaning that a is a residue. After dividing a by p, what is residue? That residue must be either 0, 1, or it can be write down as a minus 1 if non-residue. Okay, so see the definition. The legendary symbol of a by p is 0 if p divides a, or a is a multiple of p. For example, legendary symbol of any prime number. Suppose here is legendary symbol of prime is 2, and if we can write down 4, so the legendary symbol of 4 by p, after dividing by 4 by 2, we have the residue, we have the remainder 0. So 2 divides 4, therefore legendary symbol value is 0. If legendary symbol of a by p, where p does not divides a and a is a residue mod